Hello, welcome to this DVD on cone penetration testing. My name is Eric Zon and I started Lankelma in the UK in 2000. Over the years we've done a lot to promote cone penetration testing and we've learned that seeing is believing, hence this DVD. We want to show you how fast and efficient and clean the process of cone penetration testing is. How does it work? We push an instrumented cone into the ground and use a set of 20-ton hydraulic rams to do that. These rams are often mounted in a truck like this one behind me. However, we have mounted rams on jacker platforms for near-shore site investigations. We have attached them to JCBs for embankment investigations. We have put them on the box skipper, as we call it, for soft soils in Ireland. And we even developed a horizontal set of rams to do tests in tunnels, especially in London. There's all sorts of possibilities. Today we look specifically at a test performed on one of our trucks with an explanation by one of our engineers.
After the client's health and safety briefing, the CPT operator will generally walk the site with a client's representative to check for accessibility of the CPT locations and the likelihood of any buried services. The purpose of this CPT investigation is to determine the depth of piles required for the proposed warehouse building.
This is a C10 CFIP cone. This is the tip, this is the sleeve, this is the mantle. This is a 10-pin cable which receives all the data and information. This is what's inside the cone. The wires there are sending back the information via the cable. All cones and calibration files are kept in a box.
The CPT rig is then driven to the first location. The operator then engages a power takeoff, which powers a hydraulic pump from the truck engine. The operator then levels the rig on the built-in hydraulic jacks. The computer is powered up and the Windows-based recording software loaded. Depending on the type of test specified by the client, the correct cone will have been sent to site by our electrotechnician. This is then attached to the signal cable and screwed onto the first of the string of 1 metre steel push rods and the rod wiper assembly. The cone and wiper assembly are lowered through the hole in the floor of the instrument cabin. It's prevented from dropping by the rubber rod cleaning rings. 1 or 2 more rods are passed through the clamp and screwed onto the string. The cone is then lowered either by hand or by using the main hydraulic rams until it is just above the ground. The calibration of the cone is checked to ensure it is within the limits set by relevant standards. This is done using the software and the cone's individual calibration record. The depth measurement is zeroed and the test is now ready to start. The CPT rams can be controlled either manually by the operator or automatically. The usual practice is for the first metre or two to be controlled manually due to the likelihood of made ground. If, in the operator's judgment, the formation is suitable, the automatic cycle will be used. The CPT rams push a clamp and hence a CPT string downwards at 2 centimetres per second. No one touches a moving rod during the first 3 metres of penetration as an added safety precaution against buried power cables. During a standard cone penetration test, the forces on the cone tip and the friction sleeve are recorded. The signals from the cone tip and the friction sleeve are displayed real time against depth on the computer display, enabling the operator to see the material the cone is being pushed through. Depth is measured using a downward stroke of the CPT rams. Another valuable source of information for the operator is the sound transmitted up the CPT string as the test proceeds. At the end of each downward stroke of the CPT rams, the underclamp is briefly engaged to grip the rod string underneath the floor of the instrument cabin to prevent it running away under gravity in very soft soils. While the cone has stopped penetrating, no data is recorded. The next rod is screwed onto the top of the string, above the clamp, and the clamp is hydraulically raised, ready for the next 1 metre push. Successive rods continue to be added in this way until the operator decides to end the test, either due to reaching the required depth or meeting refusal criteria such as excessive load or inclination of the cone.
The test is now over, it's reached the required depth.
The CPT string is then recovered by locking the clamp in the pull position and using the CPT rams to pull upwards on the string. The operator manually unscrews and stows rods as they are withdrawn. Again, this recovery process can be either operator or automatically controlled. After the cone clears ground level, its calibration is rechecked to ensure it is still within tolerance. Time to perform a test depends on the depth of the test and the soil conditions encountered, but typically 130 to 150 metres of testing can be achieved in a day. The rig also has the facility to email test data back to the office for processing.
That's yesterday's all ready to go, by the way, all finished.
Once the data arrives at the office, it is run through a software package to give an initial soil classification.
Yeah, that looks really good.
The results are checked and reviewed by a geotechnical engineer or a geologist.
Results. That's fine.
This will ensure that the client receives correct information to assist in their design. In this instance, pile design for their warehouse. The whole report, including the soil type interpretation, is then put into PDF format and uploaded onto the reporting website. This is generally achieved within 24 hours of completing the field operations.
Thanks. Bye-bye.
From there, the clients can view and download their reports. The geotechnical engineers and geologists are also available to discuss the findings with the client. Once the string is dismantled, the operator must raise his hydraulic jacks and simply drive the truck to the next test location and repeat the process as before. In the right conditions, there are many advantages to CPT, not least the lack of disturbance to the test site.
You've now seen for yourself the efficiency of the CPT process, the minimum soil disturbance and the high quality of the reporting. The cone you've seen today was a tip and friction cone. There are many other cones like the piezo cone, the seismic cone, the fuel fluorescence cone and also sampling systems like the MOSTEP sampling. If you want any more information on any of these cones or the CPT process, you can have a look on our website lankelma.com or on the educational site conepenetrationtesting.co.uk. I hope you enjoyed the film and learned more about cone penetration testing. Thanks for watching.